All right. So unit circle. So I was talking to your pre-calculus teachers, and they want you to know. We don't cover all the conic sections, but they do want you to know the equation of a circle. Does anyone remember what the equation of a circle is without translating it? Just the basic equation of a circle centered at 0, 0. So it. I don't know if this is familiar to you. It's x squared plus y squared equals r squared. Yeah. And so let me draw you a picture of why this works. So if I have a circle like this, and the coordinates are the center of the circle, and we put it on an xy axis, which is everything we're doing in the unit circle, right? There's always this coordinate plane that's where this is x axis, this is the y axis in a circle. So if the center is at 0, 0, and we take a point on the circle. Remember, whenever you make a right triangle in the circle, always drop straight down to the x-axis, and there's your right angle. And so here's your triangle. And so the reason this is the equation of any point on the circle, let's say this is a point x, y. You go to the right x. From 0, 0, you go to the right x and up y. The reason this works is because the hypotenuse of the right triangle is the radius of the circle. And so it's y. It's because what theorem tells you that leg squared plus leg squared equals hypotenuse squared? Pythagorean theorem. Yeah, exactly. Pythagorean theorem. So, of course, a squared plus b squared equals c squared. So any center that's any circle that's centered at 0, 0, that's the equation for a point on the circle. You could solve, you could find the location if you knew 2 of the 3 things. So when radius is 1, this is why the cosine is x and the sine is y, because let's draw, for the unit circle, let's draw this right here. And let's make the radius equal to 1. So we'll make our xy coordinate system. Put our little right triangle in there. There's some random point on the circle. Make the right triangle. So let's say this is theta. This is the angle of rotation. We call that theta. And this is x. This is y. And we change the radius to 1. Then because of, basically because of SOHCAHTOA, the cosine of this angle theta is equal to what over what? Since cosine is adjacent over hypotenuse, what would it be in this picture? For relative to this angle theta, what would the cosine be of this angle? Yeah, x over 1. And so, and we don't really care about the 1, so see why the x coordinate is the cosine of the angle. In the unit circle, the x coordinate will always be the cosine of the angle. And that's why we use this unit circle. It's very convenient. It's very handy. And the sine of theta, the sine of this thing, angle of rotation is, sine is opposite over hypotenuse. So that is?
G over 1.
The opposite side is y. Yeah, y over 1. So y is the sine of the angle. And so we've...
It says cosine
of theta equals x over 1. Sine of theta equals y over 1. And then you don't need the dividing by 1. And so we've gone around with our special angles, 30 degrees, 45, 60, and we've evaluated what the cosine and sine are, and we filled in our unit circle. Assuming the radius is 1, we can actually find these side lengths if we know theta is 30 degrees or 45 or 60 based on the special right triangles. But what we haven't done is the tangent. So we're going to add that in a second. So the tangent of theta equals, and you can see tangent is opposite over adjacent. And so it's simply, you take the y coordinate and you divide by the x coordinate, because tangent is opposite over adjacent. And so what we're going to do in a second is go around the unit circle and add all the tangent values. But we have to do that we have to change to the unit circle. So, but that's the end of that. Are there any questions about why the sine is of the angle is y and the cosine is x and the tangent is y over x? It's all related to SOHCAHTOA. Yeah.
Well, actually, the question: what angle are we looking at? So
This is an angle in general. It's just theta. We're not looking at any particular
like,
angle.
where is it on? I can't see.
Oh.
it.
Sine the right angle.
Right here is
Next to the right. Is it the right angle or
It's
the
the one
one
to the
on the
left.
left?
no, it's the one to the left. So it's like if I expanded this right triangle, if I made it a little bigger, this is theta right here,
Okay.
and that's the right angle. Yeah.
Yeah.
Yes, please. So now let's look at converting from degrees to radians. It's a little bit different of a topic, but I didn't want to do notes all by itself for this. Yeah, let me finish this and then I'll go back. So to go from degrees to radians, do you see why multiplying by pi over 180 degrees is really just multiplying by 1? Because if you go around, because they're equivalent in the unit circle, when you rotate around 180 degrees, what is that in radians? 1 pi, right? Because all the way around is 2 pi. So if you multiply by this, you're simply multiplying by 1, and you can do a conversion. So for example, let's say I have 10 degrees. 10 degrees is not one of the special angles that we talked about, so we can't just convert in our head. What you do is you would multiply by pi over 180 degrees. And you know from science class, like unit dimensional analysis, the degrees actually cancel, and so your answer will be in terms of just pi. So you get 10 pi over 180. The degrees go away, and that's good because when our answer is in radians, we expect there to be pi, and then you just simplify the fraction. We can get rid of the zeros, so it's just pi over 18. So even though it's not one of the special angles, it would be pi over 18 radians is equivalent to 10 degrees. If you rotate 10 degrees, it would be pi over 18. Let's do one more example of one that we know. So let's say we're doing 60 degrees. What do we know the answer is without doing any work? And I prefer you do this. Picture 60 degrees. That's the tall. Yeah, it's pi over 3. That's the tall triangle that's furthest away. It's 1/3 pi over 3. So I'd prefer you do it that way, but let me just show you the formula works. If you multiply by pi over 180, the degrees cancel and you just get 1/3. 60 over 180, you would always simplify the fraction, and that's 1/3. So let's just go the other way really quickly, and then I'll back up and take questions. So radians to degrees, it's just you want to end up with degrees in your final answer. That's how you memorize this. So make sure the degrees are on top because you want to convert. So for example, let's say pi over 4. You can just tell me what the answer is, right? Pi over 4 is in the middle. So how many degrees is that? 45 degrees. So I'd prefer you know the answer is 45 degrees just by picturing the unit circle, but let's say you didn't. You would multiply by 180 degrees over pi, and that's easy to remember because you want the pi's to cancel when you want your answer in degrees, and then you would just do 180 divided by 4, which happens to go in evenly, but it might not always happen that way, but 180 over 4 is 45 degrees.